Hello and good morning everyone. Hope you all are having a great day today. My name is teacher Prashant and I'm back with another video on linear graph. This video is linear graph part 10, and in today's video we will be learning something new regarding linear graph. So let's move on to the next page and see what exactly we will be learning in today's video. In today's video, we will be learning what are parallel lines and what is the relationship between two parallel lines on a graph, and why two parallel lines on a graph have the same value for gradient. That's right. You heard me. Two parallel lines on a graph have the same value for gradient, and in today's video, we will learn exactly why we have the same gradient value for two parallel lines on a graph. So, let's proceed further into our lesson. Let's learn what are parallel lines. Simple definition: parallel lines are a set of lines which never intersect, meet, or cross each other. Why? Because they are same distance apart. Now, when we say that two lines are same distance apart, what distance are we talking about? Are we talking about this distance? Are we talking about this distance? Or any one of these following distance? Which distance are we talking about, and what is the contest for our distance between two parallel lines? Now, when we talk about parallel lines are same distance apart, we talk about perpendicular distance. Now, what is perpendicular distance? Perpendicular distance is the distance between two closest points of a set of parallel lines joined with help of a line segment. Now, let's understand what is a perpendicular distance. So, before we start, let's name both these lines. So, let me name the first line as line AB and the second line as line CD. So, let's take any point on any of these parallel lines. So, for example, I took the point J on line AB. Now, my question is, which point on the other line, which is CD, is the closest to the point J on line AB? For example, is it this point? Is it this point? Or is it any of these points mentioned on the graph? Which one of these points on line CD is the closest to the point J on line AB? So if we could find out the point on line CD which is closest to point J on line AB, we will find out the perpendicular distance of these two parallel lines. Now, what is the relationship between closest point and perpendicular distance? Perpendicular distance is actually the closest distance between two points, and we will learn exactly why. So let's go further into this video. So if we could find out the point which is closest to point J on line AB, we will find out the closest point of these two parallel lines. Means which two points on these two parallel lines are closest to each other. That's what we are actually looking to find out. So, what is perpendicular distance one more time? And how do we find out the perpendicular distance of these two parallel lines? In order to find out the perpendicular distance of these two lines, we have to join these two parallel lines with help of a perpendicular line. And the simple definition of perpendicular line is a line which cut, intersects, or meet another line or a set of parallel lines at 90-degree angle. And those 2 points where the perpendicular line intersect the parallel lines are the two closest points to each other, or we can say 2 points with the least distance. So, let us draw our perpendicular line which intersects these two parallel lines at 90 degree. So, this is our perpendicular line which intersects these two parallel lines at 90 degree. Why? Because this line is actually intersecting our line AB at 90 degree. And the same line is also intersecting our line CD at 90 degree. So this is our line segment J and K. So we got our line segment JK. Now let us assume that our line segment JK is 3 centimeter long. So 3 centimeter long. So we can say that the perpendicular distance of line AB and line CD, which are two parallel lines, is 3 centimeter. So, since we know that our line segment JK is 3 cm, we can say that our perpendicular distance of line AB and line CD will be 3 cm, or the distance between two closest or nearest point on the parallel lines is 3 cm, or we can also say that two closest or nearest points on these two parallel lines are 3 cm apart, which is our point J and K, which is exactly 3 cm apart, and these 2 points are the closest point of these two parallel lines AB and CD. And in order to find out the distance of two closest points of two parallel lines, we have to join those two parallel lines with help of a perpendicular line and then measure our perpendicular distance, which actually means the closest distance of 2 points on two parallel lines. And that is exactly what we did in our video. And in our case, our points are J and K, and the closest distance between our point JK is 3 cm, which is also the perpendicular distance of these two parallel lines. Now, this is where we have to pay attention when we learn parallel lines. And our point of focus is, it is not just these 2 points J and K which have the perpendicular or the closest distance of 3 cm, but the perpendicular distance of these two parallel lines, or we can say the closest distance of every 2 points on this parallel line, will be 3 cm apart. And that is exactly why we say that parallel lines are two lines which are same distance apart. And this is also a reason why they never meet or intersect each other. They never meet or intersect each other because they are placed at same distance apart. And by same distance apart, we mean the perpendicular distance of these two lines. And by that, we mean the closest distance of 2 points on these two parallel lines, which in our case is 3 cm. And since that 3 cm will be the distance of two closest points on these two parallel lines everywhere, that's why our line AB and CD are parallel, because they are same distance apart and they will never intersect each other. And that is what makes two lines parallel lines. Now, let's jump on to the second relationship between two parallel lines on a graph. Keep in mind that two parallel lines on a graph will have two different values for y-intercept. Now, what is y-intercept? Y-intercept is the value of y at a point where x is equal to 0. Or y-intercept is also the point where a line cuts y-axis on a graph. So, as we can see right here, our line AB cuts y-axis at point C, where x is 0 and y is 2. So, when x is 0, y is 2, then 2 will be the y-intercept value of line AB. Why? Because at the point where the line cuts y-axis, x is 0 and y is 2. Now, the same concept applies to the line DE. Line DE cuts y-axis at point F, where x is 0 and y is -3. That's why the y-intercept value of line DE will be -3. So, two parallel lines, same graph, but two different values for y-intercept. AB has y-intercept of 2 and line DE has y-intercept of -3. So this is the second relationship between two parallel lines on a graph, which is two parallel lines on a graph will have two different values for y-intercept. Now let's jump on to the third relationship of two parallel lines on a graph. Now the gradient of two parallel lines are always the same. Why? Because the proportion of change in y and the proportion of change in x is same since they are same distance apart. Let's see how. So let's take a set of parallel lines EF and GH, and let's take two random points on both of them parallel lines. So on line EF I took a point A and B, and on line GH I took a point C and D. So let's find out the gradient of both of these 2 points on both of them lines and check whether the gradients are same or not. So let me take the line away so that we are left only with the points. So we are left with the point AB and CD, which are 2 points of two parallel lines. So let's find out the gradient of point A and point B. Now gradient basically means change in y divided by change in x. So how do we find out the gradient of point A and point B? So gradient is change in y divided by change in x. So what is change in y? At point A, y is 4, and at point B, y is 2. So the change in y is 2 units. So we can say change in y is equal to 2. What about change in x? At point A, x is minus 1, and at point B, x is minus 2. So we can say that the change in x is 1, since x has changed only 1 unit. So now we know the change in y and change in x, which is 2 divided by 1. So the gradient of our point AB is 2. What about CD? So the gradient of point CD will be change in y divided by change in x. So how much is change in y? Change in y is the same compared to the point AB, which is change in y equal to 2, and change in x is equal to 1. So the gradient of points C and D will be change in y, which is 2, divided by change in x, which is 1, which will give out the value of 2. So the gradient of points C and D will be 2. So that's why the gradient of two parallel lines are same. Why? Because the proportion of change in y is same. Change in y at the point A and B is 2, and also at point CD is 2. And change in x at point AB is 1, and point CD is also 1. So we can say that the proportion of change in y and change in x of two parallel lines are same. That's why two parallel lines will give out the same value for the gradient. Now, before I finish this video, let me tell you the topic for our next lesson. In our next lesson, we'll be solving this question, which is find the equation of a line that is parallel to the line y equal 2x plus 1 and passes to the point where x is 5 and y is 4. Now, the only reason why we learn parallel lines and y-intercept and gradient regarding parallel line is that we have to use everything what we learned today to solve this question, which we are keeping for our next video. So, thank you so much for watching, and consider subscribing if you are interested in more future maths content, and please do hit a like on this video if this video was of any help to you. Thank you so much for watching, and I'll see you guys again in my next video. A very goodbye from Teacher Prashant.